Hello everyone. Today we're going to do packet switcher of SystemE 2 version 7, 3.3.12. Packet switcher VLAN configuration. Here's the addressing table. Objectives: verify the default VLAN configuration, configure VLANs, assign VLANs to ports. Background: VLANs are helpful in the administration of logical groups, allowing members of a group to be easily moved, changed, or added. This activity focuses on creating and naming VLANs and assigning access ports to specific VLANs. Part 1, view the default VLAN configuration. Display the current VLANs. On S1, issue the command that displays all VLANs configured. By default, all interfaces are assigned to VLAN 1. Let's go to S1. Enter. Here's the user executive mode. Enable to privileged executive mode. From here, we can use command show VLAN to display all VLANs configured. Here's VLAN 1, VLAN 1002, 1003, 1004, 1005. All these VLANs are configured. And looking at the ports, this switch has 24 fast Ethernet ports and 2 gigabit Ethernet ports. So totally 26 ports. And all these ports are in VLAN 1 by default. Step 2, verify connectivity between PCs on the same network. Same network is the same VLAN. You can see from here. Notice that each PC can ping the other PC that shares the same subnet. Same subnet is the same mean, that is the same VLAN. Okay, PC1 ping PC4, PC1 ping PC4. These two PCs are in the same VLAN 10. PC2 ping PC5. Yeah, both are in VLAN 20. PC3 and PC6, both are in VLAN 30. So let's go to ping. All these three pings should be successful. The ping PC1 to PC4 IP address is here, 172.17.10.24. Success, yeah. Because these two PCs are in the same VLAN. PC2 ping PC5. PC5's IP address is here, 172.17.20.25. Success. And PC3 ping PC6. The ping PC6 IP address is here. So 172.17.30.26. This is the success, the ping's success, and pings to hosts on other networks fail. Here is if we ping from PC1 to PC2, the ping will fail. Okay, that's because PC1 and PC2 are in two different VLANs. VLAN 10, this is VLAN 20. So let's ping PC2. PC2's IP address is here, 172.17.20.22. Because VLAN logically separates these two computers. So the computers that are in different VLANs cannot communicate each other. So the ping will fail. Yeah, here fail. Yeah, fail. Okay. So what benefits can VLANs provide to the network? At least 6. The first one is the smaller broadcast domains. Look at this network. If without VLAN configured, this network is a broadcast domain with 6 computers inside. But with VLAN configured, VLAN 10, VLAN 20, VLAN 30, VLAN 10, VLAN 20, VLAN 30, if with VLAN configured, VLAN will segment the transport, the traffic, and VLAN will logically divide these 6 PCs into 3 different groups, and each group is a VLAN. And each VLAN is become a smaller broadcast domain with only 2 computers inside. So VLAN can reduce the number of devices in the broadcast domain and improve the security because only users in the same VLAN can communicate each other. Like if we set up VLAN 10 for faculty department use and VLAN 30 for guest use. Faculty department has a lot of personal sensitive information which are not accessible for guests. So VLAN separate these 2 groups of people and improve the security. 3, improve the IT efficiency. It's because VLANs simplify network management. That's because users with similar network requirements can be configured on the same VLAN. And VLANs can be named to make them easier to identify. The 4th is reduce the cost. As we know, network upgrades are expensive, but VLAN can help to reduce the needs of network upgrades by using the existing bandwidth and uplink more efficiently, and resulting in cost saving. 5, better performance. As I mentioned in the beginning, if without VLAN, this network is a broadcast domain with 6 computers, but with VLAN configured, because the VLAN divided these 6 computers into 3 groups, and each group with 2 computers. So each VLAN is a smaller broadcast domain with 2 computers. So a smaller broadcast domain reduce unnecessary traffic on the network and improve performance. The last one is a simpler project and application management. Like having these separate functions make managing a project or working with a specialized application easier. Part 2, configure VLANs. Step 1, create and name VLANs on S1. Let's go here, S1. Create the following VLANs. Names are case sensitive and must match the requirement exactly. VLAN 10, faculty staff. Okay, let's go to configure terminal. Okay, we create VLAN 10. VLAN 10, the name of the VLAN 10 is faculty staff. Case sensitive, the first letter is capital, don't forget. Faculty / staff. Okay, VLAN 20. VLAN 20 is the student's name, student. VLAN 30, name, guest. Default. And VLAN 99, name, management, and native. Management and native, yeah. And the VLAN 150, the name is voice, capital, all capital. Okay, now let's verify. We use command to show VLAN brief. Okay, so I see the VLANs we just configured. 10 faculty, staff, 20 students, 30 guest, default, 99 management, and the native. 150 is voice, correct. verify we did it. Okay, now let's create VLANs on S2 and S3. Use the same commands. Okay, let's go to S2 and S3. Enable configure terminal VLAN 10. Name is faculty, staff. Oh, sorry, the spelling. Okay, and VLAN 20. Name is student, students. Okay, VLAN 30. Name guest, default. Guest default. Okay, VLAN 99. Name, management, and native. VLAN 150. Name, voice. Okay. Show VLAN, brief to verify. Yeah, 20 faculty, students 20, guest, management, voice. Okay, good. At the S3, do the same thing. Configure terminal, VLAN 10, name, faculty, staff, staff. Okay. VLAN 20, students. VLAN 30, guest, default. VLAN 99, name, management, and native. VLAN 150, name, voice, verify, show VLAN, brief. Okay, faculty, staff, students, guest, default, management, and native voice. Okay, good. All right, so we finished this part. Next, assign VLANs to ports. Assign VLANs to the active ports on S2. Okay, configure the interface as access ports and assign the VLANs as follows: VLAN 10, F011. Okay, here, let's go to S2. Let's go to S2. Configure terminal. And interface F011. F011. Switch port mode axis. Mode axis. When you say axis, you will know this port, this interface is connected to an end device. This here, the end device is PC1. And PC1 belong to VLAN 10. So this is the access port. So switch port access VLAN 10. Okay. Here's VLAN 20 is F018. VLAN 30 is F06, F06 VLAN 30, F018 is VLAN 20. Let's just look at the topology. Interface F018, switch port mode axis. Yes, because it connects to a PC, switch port axis. Here, this one is VLAN 20. Interface F06, switch port mode axis. Yes, switch port axis VLAN 30. This one is a 30. Let's show VLAN brief to verify. Okay, VLAN 10 is F011, 20 is F018, 30 is F06, correct. And then go to S3, do the same thing. Okay, these three access ports, F011, 18, 6, connected to 3 PCs. So configure terminal, and the interface F011, switch ports mode is axis, and the switch ports axis VLAN. F011 is PC4, connect to PC4. PC4 belongs to VLAN 10. So here's a VLAN 10. And the interface F018, switch port mode is axis, and the switch port axis VLAN 20. The interface F06, switch port mode axis, switch port axis VLAN 30. Okay, let's show VLAN brief, verify. Okay, VLAN 10 is 11, VLAN 20 is 18, VLAN 30 is 6. Okay, good. Step 3 is assign voice VLAN. The voice VLAN is VLAN 150 to Fast Ethernet F011 on S3. As shown in topology, S3 Fast Ethernet F011 interface connects to a Cisco IP phone, here IP phone and PC4. The IP phone contains an integrated 3-port switch. One port on the phone is labeled switch and connects to F04, that is integrated. Another port on the phone is labeled PC. PC is connected to PC4. And the IP phone also has an internal port that connects to the IP phone function. On S3, F011 interface must be configured to support the user traffic to PC4 using VLAN 10. VLAN 10 is for data information, and voice traffic to the IP phone using VLAN 150. As for the voice information, the interface must also enable QoS, that is a quality of service, and trust the class of service, COS, with values assigned by the IP phone. IP voice traffic requires a minimum amount of throughput to support accessible voice communication quality. This command helps the switch port to provide this minimum amount of throughput. Okay, let's go back to S3 and back to interface F011. Configure terminal interface F011. Here is MLS, stand for must label as And QoS is the quality of service, trust. COS is a class of service. Okay, switch port is voice VLAN 150. Okay, we finish configure this VLAN voice VLAN. And step 4, verify loss of connectivity. And before, in the beginning, we ping from PC1 to PC4. It was successful. Remember that? Yeah, so now let's look at here. Before is all the ports on S2 are in VLAN 1. And S1, all the ports are in VLAN 1 as well. And S3, in beginning, all the ports are VLAN 1. So ping, they're successful. And look at S2. Right now, G01 is here. It's a VLAN, still in VLAN 1. But after we assign the ports to the VLAN, so if F011 is not in VLAN 1 anymore, it's in VLAN 10. So this connected to PC1. And the PC4 is in VLAN 10 as well. This interface F011 on S3 is VLAN 10 as well. So let's ping again to see. Here's the ping PC4. PC4 is 10.24. Okay, ping. This ping should fail. Yeah. The reason, as I mentioned, yeah, before we assign the VLAN to the ports, all the ports on switches are in VLAN 1. So from PC1 to PC4, all these ports are in VLAN 1. So the ping successful. But right now, we change F011, this interface, these ports to VLAN 10. And this F011 to VLAN 10. PC4 and PC1 are in VLAN 10, but G01, this interface on S2, or the interface on S1 and S3, G02, are still in VLAN 1. That's the reason it fails, the ping fails. Okay, here's the answer. So no success because the ports between the switches are in VLAN 1. And PC1 and PC4 are in VLAN 10, PC1 and VLAN 10. And the ports between switches are in VLAN 1. So the solution is we need to configure the ports between the switches as trunk. So this G01 on S2 and this two G01, G02 on S1 and G02 on S3 should be configured as trunk. Okay, the ports between switches should be trunk. Let's go. On S2, G01 here, G01 is in VLAN 1, so we need to okay. So configure terminal interface G01 and the switch port mode should be trunk. Yeah. Okay, here this is S2, S1, both G01 and G02 should be configured as trunk. Configure terminal interface G01 switch port mode trunk, and interface G02 switch port mode is trunk as well. Okay, this is S1, S3, S3, this G02 should be trunk. Interface G02, here's on S3, okay. Switch port mode, trunk. All right, so we configure these ports between switches as trunk. Let's pin again. PC1 to pin PC4. PC4 is 1024. Okay, this one. So this time should be successful. Yeah, it's emerging. Takes a little bit longer time. All right, so let's try again. Yeah, success. All right. So here the completion status is 100%. That means we perfectly finished this VLAN configuration. Thank you for watching my video. If you like my video, please thumbs up and subscribe my channel. Share with your friends. See you next time.